In this video, I will show you one old style both tie breaker and one old style low center breaker. I will only talk about a few things concerning the breaker, but it should be enough for you to be able to troubleshoot one of these units if you ever need to. I will also show you how to replace a short power breaker, and then toward the end how to set some of the current settings for some of the smaller breakers, and a few things that I think are important to know about breakers.
Before we continue, remember, if you find the material in this video too technical, please watch earlier videos where I cover basic electrical knowledge. Keep in mind that the first 28 videos are best understood if you follow their sequential order. Now, back to our video.
One of our both tie breakers is having a hard time closing, and sometimes it doesn't close at all. To be able to troubleshoot it, I do make some assumptions since I'm not an expert on circuit breakers. So the assumptions that I make, that I expect to find in a circuit, is that it's going to be something like a feedback that will let the system know whether the breaker is in the trip position or in the closed position. I also expect that it's going to be something along the lines of a close and an open command. And I also expect that the breaker is going to receive 440 and 110. Now, these are assumptions that I have. Since I mentioned that the breaker is slow to close, I'm going to focus on the closing circuit. I do expect that the closing circuit will only be powered whenever the synchronous scope allows it, since it's very important that both sides of the circuit breaker have the same parameters for synchronizing. Also, I expect that locally, whenever the selector switch for local on the switchboard is placed, that there will be a switch that will be closed along with a breaker selector switch that tells the synchronous scope to look at that particular breaker. I also expect a local piston handle, and I expect a remote signal from EPSI to be able to close the breakers. With these assumptions, I should be able to troubleshoot better once I got the schematics. So here I got the schematics in front of me. There are 17 pages. I'm not gonna go through every single page. I'm just gonna go and focus looking for the circuit of interest, which in this case, I'm gonna start looking for the breaker. So here is the page of the breaker. Immediately, I see a breaker over here, but in close observation, I notice that this is the generator breaker. Since I'm trying to troubleshoot what is a both tie breaker, I need to find the both tie breakers. After I look through all the pages, I noticed that this is the only one that meets this criteria. And then I saw over here, these are my both tie breakers over here. So the one that I'm actually looking for is 3SB. So, but in here only has 2 lines. But one thing that I noticed is that in here we got 19 and 20. So therefore, this has got to be 19 and 20. It's got to be, since for this breaker is the closing coil, what 19 and 20 powers. That's what this one has to be powered over here. This one has, at the minimum, well, 6 lines, 6 wires going to it. This one only has 4 wires. And then there is a special note in there that I gotta go see another page. In this case, 5 TAC 113. So once I went to page 5113, I found this over here, and it gives me more information. Now, it has all the other missing lines, and it has all this, well, there is nothing really drawn inside of it. But I can use the first breaker as a reference to find out what line, or rather, what all those lines do. And a little bit of extrapolation over here, I see that 2 and 1 is the closing circuit, and 2 and 1 is the closing circuit. I did say that the breaker is slow to close. Maybe something faulty with the circuit within the breaker, or maybe it's the signal that energizes the breaker. And this one over here, it says that it's a relay K15. So now I need to find K15, where is it located. Luckily for most schematics, whenever it's a multi-page, the first page will give you a quick address of where all the relays are located. Since I'm looking for K15, it tells me that I gotta go to page 5104. You find this kind of index in schematics for elevators and anything else that has, like I said, a multi-page schematic. Now that I'm at page 104, after searching, I found, well, K14 and I found K15 over here. So K15, the assumptions that I did, well, it's a little bit different, but however, here, this is my local switch, so that when a breaker, when the switchboard is placed in local, it goes out there and closes this circuit over here. This S14, this is the actual pistol grip. So whenever a person tries to close a breaker from the pistol grip, really what they're doing is closing this set of contacts. This side over here only gets power whenever the synchronous scope says that there should be power. So in that way, if a person closes this set of contacts when the breaker is, or rather the system is out of a sequence, it will not be any power, so the breaker should not close because K15 will never energize. If K15 does not energize, the breaker will not close. Back to this schematic. So here we got the signal coming from EPSI, which bypasses the selector switch, the local selector switch. And here the local selector switch either selects local control via this path or remote control via this path. If I follow over here, I've got this K3. After a little bit of looking around, K3 in my case gets energized whenever the synchronous scope selector switch gets selected, and then by energizing K3, then you close this set of contacts and now you further fulfill the path to energize K15. So if the synchronous scope says that we got the right conditions, and if I'm trying to close a local, that means I selected S10 to have this one closed, and if the selector switch has energized K3 to close this circuit over here, whenever I press the pistol grip to close, it should close K15. After all the circuits were identified and we did some testing, we found out that K15 was energizing like it was supposed to, either from EPSI or locally, and therefore we assumed that the problem would be at the breaker. Before we went to the breaker, we still put a multimeter between connections 1 and 8 of K15, and we were getting 115 volts. As soon as we told the system to energize or close the breaker, we got 0 across over here. That is a clear indication that power was delivered to the breaker, but the breaker wasn't doing its job of closing. Today we're going to be looking at a breaker, whether it be a generator breaker or a bus type breaker. Ours happens to be a bus type breaker, but a generator breaker and a bus type breaker is not much of a difference. First thing that we're doing over here is removing these bolts over here so we can actually easily take it out. It's very important that the breaker be in the off position. You can never rack out a breaker that is on. This is how an on breaker looks like. That means it's energized. The switchboard is still energized in the back, so we're not going to be touching nothing on the back. So now we are ready to back it out, and we're going to be moving this over here so we can reach a tool all the way there. But right now we're just going to move this out of the way so we can get our tool in there. And there the breaker comes. Here means that the breaker is already disengaged, but for our case we need to drag it out more. Now, in this side over here, when it was this line was aligned with this edge over here, that means it was for testing. After that was the disconnected position. But to be able to work on it, we took it out to the fully withdrawn position, which you see the line over there. Back over here, you can see where are all the connections where the switchboard actually connects to. And here we got the anti-arc chutes, and the main ones are, unfortunately, it's in an angle that I cannot really get a good picture of. To trip the mechanism, in here it just said turn clockwise and just press in, and it was just tripped, so that's working just fine. Yeah, it is definitely going up as you are.
Actually, this is that part.
What? You put all the way up.
That's it?
You hear click? Stop.
Right here on top, you see a whole bunch of switches. Okay, these are they open and close based on the position of this rod. This rod is mechanically interlocked to all the mechanisms so that when the switch or the circuit breaker opens and closes, it just simply gets guided. I'll show you what I mean by that in a moment. The way how this particular breaker closes, it uses a big plunger, which I show you all the way at the bottom. Which is, well, that one over there. Now, when I look at the schematic, energize the circuit breaker, pretty much this coil has to be closed, which gets power from this rectifier, and on one side of it, it always gets power from 20. The other side, it gets power, but look over here, it's open. So that means that CR has to be closed. When CR closes, but that means when CR energizes this coil over here, then that closes and the breaker, well, everything closes. What causes CR to energize? If you see, CR is fed via this rectifier. So this rectifier has to be energized. So whenever a signal power is applied between connections 2 and 1, which once again, in this case 2 and 1, it will be the first 2 all the way there that will bring the signal, and as soon as that is energized, it will give power to this rectifier. This IMA contactor has to be closed, and this over here is the closing coil. So this closing coil, well, it is that big coil that I showed that it went up, and it has gets power from some rectifiers. There is always powers at point 19 and point 20, which I will show you right now where this 19 and 20 are, or where do they get power from. Just I want to note that, see this navel, these 2 arrows over here and 2 arrows over here, that means that these are connections outside of the circuit breaker. This is how it connects to the actual switchboard. All of these ones are connections to the switches, and switches, what I mean is these switches over here. These switches over here, it is what I'm showing you over here, and all of them they intertwine to different connections outside of the circuit breaker, okay, into the switchboard over here. Now, I'm about to show you what are these 5, these 9, these 19. For example, I'm gonna particularly focus on the ones that energize 19 over here. I'm just trying to get my focus, and 20. Underneath of the breaker, we got all these connections over here, and 19 happened to be that one, and this is 20. Everything it's very difficult for me to get there, but it starts with 1, 2, 3, 4, and if you follow, all of them are numbered, and they actually have connections over here. All the way in the back over there is where it's waiting, so when the breaker gets back in, to get connected to all these fins to make actual contact. As you can see, these pins are spring loaded. See, I'm pushing. So once again, 1 and 2 get powered, and as long as IMA is closed, this rectifier gets energized. It energizes CR. CR goes out there and closes this set of contacts over here, which now the rectifier over here sends power to the closing contactor, and that whole plunger and the whole breaker immediately closes. So you unlock today because we are able to drop off all this connects, well, this little plate. And I can easily now get access, show you, what are these called?
The diodes?
These are diodes, okay? And 2 diodes over here, 2 diodes over there, so that is a bridge rectifier right there, okay? That's one. And then we got another rectifier over here. Remember, this one energizes, when this one gets energized, it powers our relay CR1, and then CR1 contact, when it energizes this rectifier, and this rectifier sends power to our main coil, and that's how this breaker closes. All right, fellow YouTubers, please don't tell on me, but we're about to do a bench test over here. So I went ahead and connected this to a connections 1 and 2 of the breaker, okay? Because the breaker, it's
is sometimes it closes, sometimes it doesn't. And 1 and 2 really energizes CR1. This is CR1 over here. So we're gonna bench test it right now. So please go ahead and energize it. And go. De-energize. Energize. All right.
Labeled
All right. All right, so here's inside the switchboard, and there is a relay called K15 for a particular case, that when that relay energizes, is the command that sends power to this relay to initiate the closing. So this one, I just found out that it's sticking. All right, so please go ahead and do it. And now come back to here. No.
You missed.
Okay. Now I did it, not a problem. Go ahead and see, it's getting power, but it's very slow. On top of the circuit breaker, we have this linkage over here that obviously gives feedback based on whatever the position of the breaker is, whether if it's off or open. So in a moment I cycle it and I show this in actual motion. So experimentally, we discovered that these and these ones over here are open right now because the breaker is in the off. However, the second row and the one that is hard to see at the bottom, right now they are shorted because they are in the off. As soon as we shift the breaker, those readings are going to change. Let's go ahead and take the reading right now. So that's our short one, which is the second. The bottom, which is the third set of switches, they are open, and all the way at the bottom, right now they are shorted. These two are open. Now we're gonna trip the breaker, or rather engage the breaker. And we're gonna take the readings. Remember that a moment ago this one was open and this one was open. Go ahead and take your readings, please. Short it. Open. Short. And the last set, which is the bottom set, are open. Now, remember, this is one set, independent switches. So we got 1, 2, 3, 4, 5, 6 sets of switches all together over here. And this is how the breaker gets a feedback to either let the system know that it's open or closed, and also to protect the interlock for the solenoid, so that the solenoid only gets energized just long enough to either open and close the breaker. Not all the switches get used. As you see, there's a lot of spares, but all of these wires, okay, they travel all the way to the back, and they make connections, or rather they're connected over here to all of those pins, ready to finally make connection when the breaker is closed, all the way down there. Which all right, go, trip it. Now close it. What are we looking for in here?
A little bit. So looking at these, make sure it's not corroded. I got little burn marks right here. Kind of cleaned it off a little bit.
Okay.
Says that this is all good.
Okay. And how it goes back on? And this is the R shoot, right?
Yep, the R2. Straight in. I need full pump.
All right. Let's take a look at the bottom of this breaker. So to start, here, all of these are the electrical connections that allow the breaker to communicate with the switchboard. And in the inside, first it starts with this solenoid. This is the one that actually opens, take that back, it closes the breaker really fast. And then after that it just gets latched. So I'm not quite sure, and I never took the time to really look at all these components because they never break, so therefore if it's not broke, I don't try to fix it. But I did notice that there's a relay back over there. That looks like a resistor, and I would like to take a look at things when I'm troubleshooting so that if they ever break and I'm looking at the schematic, I can already know what to look for somewhat. Now to this side over here, we got two transformers, as you can see. Now different breakers might have them located in a different place. This is how ours are. And I noticed that on top there is a rectifier, which I'll show it to you in a moment. And there is the rectifier. And like I said, I just like to be familiar with some of the components so that if they ever break, I'm not starting from zero. And also, remember earlier I showed you how this works. As a matter of fact, I'll show it to you again. So right now the breaker is closed. We're about to release, so you pay attention to that. And anyway, that's to provide feedback to the actual switchboard. And then all of those cables, like I pointed out before, here is where they make connections to all of these legs. And if you can see all the way in the back there, that is the other matching end that will be connecting the switchboard to the breaker. So for us to do the maintenance, we had to actually take it all the way out. But whenever we just doing switchboard cleaning, that we want to disable the circuit breaker in a blackout position, we only take it out to this point over here. Just pull. Pull hard. Alright, so here are our shore power breakers. And what about, this is the motor operator that actually opens and closes the breaker. The breaker is all the way in the back, and we're gonna open to install that breaker, because you see that one has it, that one doesn't have it, because the breaker is right there. So when we got valuable power from shore power, we get white light, and then when the breaker closes, to let us know that the other side of the breaker got power, then the blue light comes on. In our case, to remove the operator first, we need to mount the light. So we remove this. So this is the motor operator, and this is what actually causes the breaker to either open or close. And that's what I'm going to install the breaker. So here we got the insides of a shore power breaker motor actuator. As you can see, also comes with a schematic, which is pretty handy if you know where is it located. And this is the actual connect plug, this here on top of it. As you can see, 3 connections in there. And right from the get-go, there is a switch all the way inside there. I did not even know the location of that switch. And the motor itself. The motor happens to be a universal motor, and that means it can work with AC or DC. Here is the actual commutator for the motor, and the other part, okay, the cap that goes in there,
You can see the brushes all the way at the bottom, and well, the two windings. As far as the switch, it's over there. It's a toggle switch, a really simple system that I'm gonna show you from the side. And I hope that you can see inside there's a switch. I'm gonna, as I'm gonna move this to simulate that I'm opening and closing the breaker, you see that the switch easily gets engaged and disengaged. Now let's see how it works. Looking at the schematic over here, like I said before, the motor, well, it has three connections. One over there, which is white, and it will always be energized. And then after that, black, it will be my command close, and red will be my command open. So let's take a look at the black connection right now. So this cable over here goes in, it goes into that terminal board. This terminal board over here is inside of the breaker. So it connects through the terminal board through the switch, which when the breaker is open, this contact will be closed, and that's perfect because now it will connect to one over here, which is to alpha. So whenever you put power between alpha and Charlie, now power will go through the closed switch to energize the black cable, and as soon as this part of the winding energizes, the breaker will shift, and that will cause the breaker to actually close, and then this switch over here will open and this one over here will close, and that is important because that's what it causes the breaker from the stop getting the command to open more. Otherwise it could damage the motor or it could break the breaker. Now that we completed all the connections, we're about to connect the show power breaker. So that is the actual carrying contacts that they're gonna match into here. The new breaker has with already installed screws that won't come out, but we gotta use these long ones. So for that, we just simply remove the frame. So we can take this out. Since I got this open, these are what is called the R chutes, and these are the switches that will let me know what's the condition of the breaker. This solenoid over here is for the shunt trip. So this is the one that trips the breaker. A common, and the other two, one is command open and the other one is command close. And so the breaker now is in the back. So these packs over here are just for the fuses, and even these little breakers, you also have the fuses over here. This over here is actually to adjust the current capability of this amp. And the reason why you have three of them is because you can adjust how many amps are going through each of the phases before the breaker trips. The settings for this type of breakers, you will actually have to remove the internal part, and then all the way back over there you see these little markers. When the breaker is installed, I recommend to use a screwdriver to do them. You should never have power at this point on when this is removed, because if you notice, this top is no longer pressed, and when we install this one, it gets pressed, and what it does is that it allows at least power go from the back into one of these sides, and then the other one, it goes into the actual load. So It's a safety feature so that if you were to remove one of these things, and if you were to accidentally touch inside there while the system is still energized, you shouldn't get shocked. It's a safety feature over there, but I'm not saying take this out and stick your fingers in there, because what if the safety feature fails? So here we are replacing a breaker, and the top side, that's where power comes in, 3-phase, and then that is actually the low side. It connects to the back. The back of the breaker, it should just be, well, perfectly rounded like that. This is actually composed of 4 little sections, okay, that they are put together by the spring. So what I'm saying is that the spring comes off, these teeth per se, they will just fall to the sides, 4 of them, but you can just put it back together. It takes a little bit of